Have you ever wondered what would happen if an area of your city had a zoning change or a new transit station was created? How do new constructions influence future development decisions in their surroundings? CityCompass is a tool that helps you analyze and evaluate these changes. Through the application of a high-precision land use simulation model, operating with large amounts of data, CityCompass simulates scenarios that show the impact of urban events. But how does it work? You can set your own hypothesis for the future of the study area. Create the projects that you want to add to your scenario. Let's start with a new building. What kind of views does it have? At the maximum height, the year that the construction will start, and the time it is expected to be finished. Draw the footprint and the height will be extruded automatically. Configure your hypothesis for its effects in its surroundings. Now, let's try renovating an area. Add the period of time that the task would take. Draw the selection and adjust its impact. Urban barriers and discontinuities in the urban fabric will diminish the effect of the event. A central element of the model is a set of real estate agents that will compete for the land to take advantage of positive effects of new policies. Each agent has a unique algorithm based on the risk profile and the building typology, evaluating the price of the land, the buildable capacity, financial incentives such as soft credits, and the amenities surrounding the parcel. Land prices evolve over the years as a result of interactions between supply and demand agents that transact in the context of a market equilibrium algorithm. This model allows not only to compute thousands of pro formas in less than a second, but also to simulate complex dynamics between hundreds of agents. Adjust the amount of soft credits available. Set the construction cost for each building typology. State the number of agents and an average of capital per agent. Choose the period of time that you wish to simulate. Regulate the parameters for the demand, determining the number of agents according to the size of the units and applying an average of available capital per agent. Customize your scenario by evaluating your own zoning changes. For zoning creation, pick the maximum height, the rear setback, and the year when these changes will take effect. Select the area you want to act on. You can also edit the parcel data by right-clicking and simply overwriting its attributes. You can even disallow developments to take place in that space. Once you set all the constraints of your scenario, press Simulate, and after a few seconds, it will be possible to visualize the forecast. Navigate through the years using a timeline discovering where new constructions will take place and how the price of land varies. Select the data layers you wish to visualize. Add the urban fabric to the main map, the buildable capacity, and parcels. Analyze the study area accessibility. See the accessibility score of each parcel, depending on its reachability by different transit modes of retail and services, schools, parks, health infrastructure, and sport facilities. Add a new amenity on the map and the year of completion, and see in real time how it will affect the accessibility of the area around it. This will also affect incentives for the demand side of the model, which will attract new residents. On the timeline, you can see a snapshot of the construction pipeline for the area, color-coded by building type and type of agent. The table will give you a more accurate sense of prices, building capacities, and pro forma results. Visualize results with charts, understanding the population, construction employment, and housing growth, or see how supply and demand interact in the area, and compare the energy consumption between the newly constructed apartment buildings and a traditional single-family house unit in the suburbs. For more information, follow us on LinkedIn or contact us at info@urbanly.org.